Welcome to part 2 of the discussion on building scalable and fault-tolerant job queue. So in this video we'll cover an important aspect of the design, that is, how do we recover a job from a worker which has failed to complete it. Now the question is, when can we consider a worker as having failed to complete a job? Different job types could take different amounts of time to complete. So to address this, what we can do is we could define a time period delta specific to each job type. Within which each job has to be completed by the worker. So this is the delta time period that we are defining. So if this job is not completed by the worker within this delta time period, we can consider that the worker has failed to complete the job. Using this concept of providing a safe period for a worker to complete the job, we can now think about how can we go about recovering failed jobs. So if a worker fails to complete the job in the delta time period, what we can do is we can push the job back onto the job queue so that another worker can pick it up and work on it. Now let's consider how to achieve this. Now consider our earlier design. We had a job queue, and then we have multiple workers which were vying to pop the jobs from the job queue and then work on it. Now what we could do is, when a worker pops a job from the job queue, we can hold it in a temporary store, hold a copy in a temporary store. So let's say if this worker has popped this job and started working on it, we can hold a copy of this in a temporary store. And then if this worker has failed to complete this job within the delta time, we can then push it back onto the job queue so that another worker can come and pick up the job from the job queue and work on it. Now, point to note is that there could be multiple jobs that might have been failed to be completed by workers. And what we might want to do is we might want to actually queue such jobs so that we can recover such jobs, push it back onto the job queue in a first in first out manner. So this store has to be a queue. So we'll call this as a temporary queue. It's essentially a temporary storage. A few things about the delta time period that we defined earlier. This delta time period can also be viewed as the time after which a job currently allocated to a worker becomes visible to other workers. Right? So the idea is that if a worker fails to complete the job within that safe period, now the job is visible and hence available for other workers to pick it up. So henceforth we'll call this delta time as visibility timeout. So now let's consider the steps that are essential for recovering a job. So when a worker pops the job from the queue, a copy of it is placed in the temporary queue until two things happen. Either of these two things happen. One, the worker completes the job. If the worker completes the job, we don't want to keep on holding to that job in the temporary queue. What the worker can do is it can come back and it can just delete the job from the temporary queue, thus indicating that it has completed the job. The second thing is, the worker has not completed the job within the visibility timeout period. So thus we consider it as having a worker having failed to complete the job. So in that case, what we want to do is we want to then pop this job and push it back onto the job queue as we discussed earlier. So what we don't have is, so failed jobs, we need to push it back onto the job queue. So what we don't have is, we don't yet have any component which can do this, which can essentially look at the jobs which are there in the temporary queue and determine if they have failed, and if they have failed, then push it back onto the job queue. We don't have a component for that. So this component, we call it a recoverer. It recovers the jobs that have failed to complete and pushes it back onto the job queue. Now this solution looks good. It achieves what we set out to achieve. But there is an important nuance that we are yet to consider, which is, how does the recoverer know that it's safe to recover a job which is there in the temporary queue? So only if, let's say, a worker has failed to complete the job within the visibility timeout period, it has to push such a job onto the queue. But how does it know that? That question we have not answered. So these questions are essentially about how do we design this concept of visibility timeout. So I first came across this concept of visibility timeout when I was learning about Amazon SQS, or simple queue service. Amazon SQS uses this concept to determine when a job has failed execution, like the way we define, and also when it's safe to allocate that job to another worker. So let's think about how we design this, how we can design this visibility timeout. Now we can think of visibility timeout as a lock on a job placed by a worker to indicate that it is working on it. But the important aspect is, this is a lock which expires, and it is set to expire for a time period of visibility timeout. So thus the lock expires in a time period equal to the safe time period required for the worker to complete the jobs of that type. Now, if the recoverer, let's say, if it looks at a job in the job queue and then finds out that, hey, there is a lock on this job, that means it knows that a worker is still working on it, and it can still come back and complete the job, and it can thus delete that job from the job queue. So it leaves such a job alone. But if there is no lock on the job, and if that job, essentially it looks at the job queue and finds a job, and if there is no lock for that corresponding job, that means that the worker has failed to complete the job and has hence failed to delete that job from the job queue, from the temporary queue, and hence it can recover it. Alright, so now we have pretty much designed all the components necessary to implement our job queue. So this design essentially covers all aspects, which is scalability, fault tolerance, and recovery of jobs. So in the next video, we'll look into how our design maps to the data structures in Redis, various data structures in Redis, how they can support our design, how we can implement our design using Redis. It will also, the next set of videos will also cover the details of the implementation. We'll go in depth into the implementation and of course a demo of the project. Thank you for watching.